Next curve.
Hello, my name is Leonard Lee. I'm the founder and managing director of NextCurve, and we are a research advisory firm based in San Diego that focuses on exploring and charting the white spaces and emerging market opportunities forming at the intersect of transformative technologies such as cloud, AI, 5G, IoT, and much more. Today, I'll be talking about 5G IoT. Are we ready for both? Are both ready for each other or not? This really is the big question, right? 5G is supposed to be the industrial mobile wireless generation that transcends the mobile network's long legacy as a network for the cell phone that has evolved into the smartphone that we all cherish so much in our lives today. So let's start with what is 5G? Well, it's just another G, but like any other G, it's different. And it's an advancement, and hopefully a better one. Simply put, 5G is a continuation of 4G, also known as LTE, with new technical objectives set by the ITU through its IMT 2020 requirements for 5G. Some of you might be familiar with the three usage scenarios for 5G, widely known as EMBB, or Enhanced Mobile Broadband, MMTC, or Massive Machine Type Communications, and the notorious URLLC, or Ultra Reliable Low Latency Communications. Thanks to some robust and ambitious marketing by mobile network operators and technology firms preceding the actual setting of the Release 15 standards by standard defining organizations, or SDOs, there is a lot of talk about sub-millisecond latencies, 6 nines industrial reliability, ability to support 1 million connected devices in a square kilometer, and 20 gigabit per second data rates. Unfortunately, these are mere targets that the 5G technologies and networks will evolve toward over the next decade, or maybe even two. So 5G is also very well known for millimeter wave spectrum, which is the marquee frequency band in the 24 gigahertz to 100 gigahertz range. And the hope for 5G has been and continues to be that this massive bandwidth opportunity will provide massive capacity along the mobile wireless access network that will enable a bunch of aspirational 5G applications, such as the much touted autonomous vehicle, AR/VR, and the infamous intercontinental remote roadside robotic surgery. The industry has a tendency to view the usage scenarios as mutually exclusive of each other. Of course, they aren't, and it's unusually common to apply an either or to the 5G scenarios as we brainstorm through applications. And the 3GPP recently announced 5G Advanced, which will be the official designation for Release 18 and beyond until the requirements for 6G are issued by the ITU. It is yet to be seen how Release 18 will take form, but some 3GPP members who are involved in the 5G Advanced early discovery work are thinking beyond the triangle, that familiar triangle, and taking on a more cross-functional perspective on where 5G needs to go. Early in 2020, Huawei proposed 5.5G, which looked at the intersects between the original 5G use cases. Huawei suggested that the specifications and technology should evolve towards supporting use cases that are blends of, let's say, URLLC plus EMBB, which Huawei dubs real-time broadband communications, EMBB with EMTC, which they dub uplink-centric broadband communications, and a very 6G-ish concept called harmonized communication and sensing, which is a blend of MMTC and URLLC. LLC. Well, that was a mouthful of acronyms there. Hopefully you all got that. But based on our research, Huawei has been reacting to the needs of critical industrial environments that would not only require reliable and low latency communications, or URLLC, but also the simultaneous support of massive bandwidth. And given the current geopolitics and the increasing politicization of the global standard making process, we'll see how much of their proposal will prevail on their technical merit. So what is the state of 5G? Well, simply put, we're still in the very early stages of 5G. In July of last year, Release 16, 5G specification was completed. With Release 15, which was completed in 2018, we've been living with a blend of LTE and 5G. Basically, 5G running off of LTE core, or what is commonly referred to as non-standalone 5G NR or new radio. It's only this year that we've seen a small number of major regional and multinational operators light up standalone 5G NR networks running a 5G core. T-Mobile is the first to launch a standalone 5G NR network in August of last year. And since operators in South Korea, China, Japan, Australia, Kuwait, Germany, Spain, Canada, and Singapore have deployed some level of standalone 5G NR network. And we're also seeing a limited number of devices out today that support Release 16. So many of the first stage industrial features of 5G are not widely available, such as time-sensitive networking and enhanced URLLC capabilities. Excuse me. So what does 5G mean for IoT? Ultimately, the question is, where are the value opportunities along the 5G journey? And for the Internet of Things, 5G will progressively change the game. It'll bring about an expanding palette of connectivity that builds on top of LTE cellular connectivity with features we've not seen before. And unlike LTE, 5G offers and will continue to build out industrial-grade capabilities, performance, and security over the air. And this is a big deal. Just to be clear, that does not mean realizing these new capabilities are or will be easy, but we can rest assured that it will get better, easier, and cheaper. This is simply a fact unless you're one to wager against human ingenuity and the persistent advancement of technology. So let's walk through some of the compelling features that have been specified to date and are in the works with Release 17, and I'll share a hypothesis for what Release 18 might bring about, and highlight some of the work items in consideration by the 3GPP working group working on this release. So let's talk about what we have with 5G up to Release 16. Release 16 really hypercharged the feature portfolio of 5G, including enhancements to NB-IoT, new radio positioning support or NR positioning support, new UE or user equipment power saving features, and much more. It also introduced the first tranche of industrial features such as time-sensitive communications or networking, URLLC, 5G private network support, NR-based access to unlicensed spectrum, which was a big deal, enhanced network slicing, and enhancements to location and positioning services and capabilities. The emerging support for massive machine-type communications for the IoT was another thing, and the proposition here is to support millions of devices in a square kilometer. And at the moment, there are still far too few 5G IoT devices out there to drive this requirement in the early 5G networks. We have seen some early launches of NB-IoT services with modest traction outside of China. Now, Release 16 also takes the evolution of cellular vehicle to everything communication, or CV to X, that was introduced in release 14 in the 4G era to the next level with new side link capabilities such as reliable multicasting and distance-based group formation. And this is a feature that is currently being heavily pushed by 5G AA and 3GPP member ICT companies such as Qualcomm, Ericsson, and Huawei, as the auto industry makes an ardent push toward smarter and connected vehicles. So there's a lot to be excited about for what is slated for commercialization in the next couple of years with release 15 and 16. There are also a lot of new applications that will need a lot of sensors, and this should be good news for all the sensor companies attending this conference. Now let's take a look at release 17, which is expected to be completed mid-year next year. This release is currently in the works and will bring about expected enhancements to many of the industrial and IoT related features of release 16 and prior. Some of the interesting work items of note from release 17 include IoT and 5G NR communications over non-terrestrial networks or satellite. Low complexity NR devices, also known as RedCap or reduced capability devices, which allow this allows reduced capability devices to operate in any of the NR frequency bands with improved support for low power consumption devices such as wearables, industrial sensors, and video surveillance devices, among many others. And there are also enhancements to edge computing, also known as MEC or multi-access edge computing, for the 5G core that we can expect out of this new release. And finally, let's entertain some ideas for what Release 18 will bring about. Release 18 is a bit of a transitional release. And it is in the initial phases of planning at the moment. It's also the first of the 5G Advanced series of releases expected to be completed in 2024, possibly 2023. The crux of Release 18 focuses on continued evolution of mmBB-driven features, which are an MNO priority, frankly. The continued advancement of non-enhanced mobile broadband or eMBB-driven features for industrial and vertical applications such as the connected car. And third, cross-functionalities for both eMBB and non-eMBB evolution according to the 3GPP. So this is according to the 3GPP and the working group that's working on the early phases of Release 18 planning. And these baseline priorities suggest a few things. Firstly, many industrial applications require enhancements to uplink performance and latency from the UE or the user equipment. And for the most part, the feature focus of previous and current releases have primarily been downlink focused, which is not surprising given MNOs seeking to accelerate network deployments, coverage expansion, and enhancement of features that drive their core and new revenue opportunities, or what they suspect will be new revenue opportunities. However, if industrial use cases and applications are to proliferate with 5G, the ability to quickly and massively communicate data from endpoint device to the cloud or edge cloud will be vital, especially for mobile wireless control systems. So Release 18 will explore uplink features such as enhanced multi-TRP uplink operations, frequency selective or pre-coding, and coverage enhancements for uplink communications. And energy saving and efficiency seem like an important priorities that Release 18 will address, as sustainability appears to be a key priority in 5G Advanced going forward into 6G. Sustainability and energy efficiency will be increasingly important, especially as efforts are made to make higher bands more usable, more economically viable against growing concerns that the new network will be an energy hog. And many of the proposed work items address energy efficiency, low power consumption devices, and sustainability as a whole, from the endpoints to the RAN to the core network. The connected vehicle is also becoming a bigger thing. Release 18 builds on C-V2X and Sidelink with enhancements in positioning functions to enable advanced location-based applications and functions. All of these releases and associated features will continue to build out a wide range of industrial-grade features that require a degree of global standardization, and this should be exciting for many industries that are looking for the benefits of cellular connectivity and global interoperability with industrial grade capabilities. What will 5G mean for the devices that you are designing and connecting to the IoT? And the simple answer to that question is in many ways, depending on when it makes sense. And as I covered prior, 5G will bring some revolutionary features for mobile wireless communications that were not possible before, but for many, not quite right now. However, these features will be realized in the market over time. And even if you wanted to take advantage of some of the 5G URLLC features in Release 16 or more enhanced features of Release 17, they largely don't exist today in the wild. They're coming, and it's frankly inevitable. Again, it's all about timing. But let's get practical about the matter. As you look forward to 5G and the possibilities it presents to connect your devices to the Internet of Things, there are 5 things that you want to consider. Let's talk about security. For some reason, most presentations about 5G and IoT and pretty much anything digital put security at the bottom of the list. I'm going to reverse that and put security first and get on my soapbox here. Security is paramount. If your device and solution, your solution system that it connects to is not secure, scrap it. Don't go to market. Don't do a disservice to yourself, your customers, and society. Put security first. Sadly, I know this statement will be largely disregarded, but it has to be said. And thankfully, 5G will provide options to design and deploy secure, connected things to secure systems for industrial class applications and use cases. The advent of eSIMs and iSIMs avail new possibilities for deep device level security in your network and on devices. So the next thing to consider is design constraints. Consider this endpoint design constraints that you're dealing with in terms of compute, size, endurance, durability, manageability, and serviceability requirements. For many IoT endpoint devices, the antenna design and radio front end will be important depending on the spectrum band you'll be using for the application you're building. Millimeter wave is particularly tricky due to the range and propagation characteristics of the spectrum. Antenna placement will be important. In short, the diversity of 5G bands will make things complicated, but that comes with the benefit of more options. The next thing to consider is technological maturity. The 5G promises won't be delivered in bulk today, as I've said before. It's going to be a better part of a decade or more. As you consider your current device designs and future roadmap, consider the commercialization path of 5G features of interest and timing. Not just the 3GPP release for the technical specifications of that feature. This is some significant lag that you have to consider depending on the feature. The next thing to consider is 5G service maturity. For many emerging industrial applications, in particular 5G network service quality and coverage are important. Whether you're talking about public or private 5G networks. The maturity of these services should factor into your initial device designs even before the device. This factor should be considered in the solution system design. And at the moment, many of the more advanced industrial features of 5G are difficult to find, like I said, in the wild, even the most progressive 5G network deployments to date. And for many of the URLLC or URLLC plus eMBB scenarios, network design, testing, assurance will be very important, as the idea of deterministic networks is a novel concept to the cellular universe, as is the delivery of 6 nines reliability to and from the endpoint to the RAN. The next thing to consider is system architecture. Over time, 5G will have a profound impact on how compute and computing architectures can be distributed across the system or network environment. Emerging MEC-based edge cloud services will provide options for how computing functions and workloads can be placed in an environment or across an MNO's network and edge cloud environments. And these design options should inform how your device can be optimally designed for the current state of 5G technology and 5G connectivity services. And finally, the most important consideration, economics. Does the architecture and the computing model that you are considering make economic sense? The thing that I hear all the time in the IoT community about 5G is that the modules are too expensive compared to other options such as 4G or the connectivity services. And or quality are simply not there to support the solution that their devices might enable. And in the end, economics are going to determine if your device and the IoT solution or application enables or plugs into makes sense. And of course, the result of that equation will change over time. Where will 5G matter for IoT? And for the moment, the differentiated use cases 5G have frankly not arrived as of yet. And some operators and technology firms may argue this point, but most of these use cases have been implemented largely on a trial or pilot basis. That is not to say that there aren't production implementations of 5G networks, most notably in ports. However, if we're to get past showcase implementations, we need to see the broader commercialization and implementation of Release 16 features before we see momentum in end market adoption. So, getting back to the question, will 5G matter for IoT eventually, is pretty much the answer, eventually. It really is just a matter of time, and it will change the way we design systems, how we design devices, and how we architect digital services. In principle, 5G differentiates itself from 4G, Wi-Fi, and wired in critical applications that require URLLC over the air. It's even more differentiated for mobile applications. And then there are the more demanding applications for URLLC plus eMBB that we mentioned before. It'll be vital for autonomous industrial systems of our imagination that will require high performance, ultra reliable symmetrical networks with reliable and high performance uplink and downlink that will enable these intelligent mobile wireless control systems. And that means being able to send large streams of data from sensors and endpoint devices that provide perception functions up to an intelligent function in the cloud, and then push control signals and orchestration back down to devices in the field with low reliable latency. And of course, all of this will be done with low latency and some degree of industrial grade reliability, say 3 to 6 nines. One of the most important selection criteria of 5G in this capacity is the need for mobile wireless connectivity. And I just say this again because this is something that seems underestimated as we explore possible use cases and value cases for 5G. I know it's a little bit weird, but Yes, it's a little bit aspirational, but let's face it, industrial IoT is not about streaming 4K Netflix video to millions of IoT devices. It's about putting as much intelligence as close to the sources of data and offloading compute-intensive workloads up toward the hyperscale clouds across the edge cloud continuum. Now that means sending data up. Especially in the mobile context, 5G will be critical, and it will definitely open up new possibilities for how distributed intelligent control systems can be architected, built, and operated. And for perspective on this, refer to our white paper on 5G autonomous edge sponsored by Intel, which we published last year. In my opinion, to a lesser degree, the MMTC plus URLLC, or what Huawei dubs harmonized communications and sensing, might be a close second in terms of unique 5G capabilities versus available MMTC competing technologies such as Sigfox and LoRa. Deterministic long-range IoT networks is a big deal in that it'll enable 5G to offer a differentiated option to Sigfox and the growing LoRa networks. And what that would look like, it's still a mystery, but it is an interesting concept and an area to monitor as NB-IoT continues to evolve and newer industrial 5G features for macro IoT scenarios are specified and eventually commercialized. Now, I find the EMBB plus MMTC applications interesting, but not something that will cater to the high-value applications for 5G. At least that's my assessment at the moment. Of course, that perspective might change. I'll let you know when it does. It might be a good reason to follow me at Next Curve Research. As I mentioned, these are the capabilities that I see that are differentiating for 5G as it continues to evolve versus options. The bottom line is that wired for many industrial use cases is still king. I'm not going to lie. The good thing about 5G is that it will enable us to imagine and eventually realize mobile wireless alternatives to how we do things today. Maybe not today or tomorrow, but definitely in the reasonably near future, near midterm future. Okay. In closing, device makers should consider the following as prudent practices and steps as they look at 5G and the opportunities it can offer in the future of, for your customers as well as your business. So firstly, get a real feel for the 5G technology roadmap. Get a sense of the timing of 5G features and ensure that you understand the path to global standardization and commercialization. You don't want to get ahead of yourself or lose out on an opportunity by getting in the game too late, though I think the latter is the lesser concern of the two. Second, understand the quality of 5G network deployment and service availability in the markets you're targeting. From a private network perspective, consider the economics of connectivity in your assumptions for the market opportunity for the broader solution beyond the device that you're bringing to market or participating in with partners for enterprise customers. Private 5G is pretty new and it's comparatively expensive at the moment and challenging to manage compared to Wi-Fi. The good news is that these issues will be addressed in due time. Thirdly, right fit the 5G connectivity that your application needs. Obviously, you'll want to understand the band that your device will connect through. Given the wide gamut of spectrum bands that 5G traverses, make sure you consider radio design as you design your hardware. And if you don't, you might end up with a funky device with funky performance characteristics, and you definitely don't want that. And finally, think in terms of the entire system design. I find that too many solution architects and hardware engineers take a siloed perspective on device design. Understand how 5G will change your assumptions for device designs in the broader, context of the broader system. And while the initial hype and excitement for 5G has waned a bit, I think that's a good thing. There are real exciting opportunities in the present and the future to capitalize on the industrial grade features of 5G that are unique to 5G. And with that, I'd like to thank Fierce Electronics and the Sensors Converge event team for inviting me to speak. If you'd like to get in contact with me and NextCurve, here's my contact information right below. And I hope that everyone has a safe and fruitful time. Best of luck with 5G, and enjoy the rest of the conference. Thank you.
Visit us at www.next-curve.com.